Hello everyone, welcome back to my video. Thank you for your continuous support. I hope you will like my video. Now this is a second part of my Form 5 Chapter 3 integration. Last part, part 2. If you have never seen my part 1 and you want to learn about integration, it's advised to stop this video and go back to part 1 so that you will get the concept right before proceeding into part 2. In my previous video, I've gone through indefinite integral, whereby the integration law that I have shown you in the previous video. You should go to video part 1 before going through this part, where indefinite integral is integration without lower and upper limit. And also we have gone through forming of equation. You were given a gradient and then you were asked to form equation with a constant c for both what we have learned last week. The reason to why you need to have a constant c because it's an indefinite integral. Now, I've never mentioned the reason, or I've never told of the actual meaning of integration, so I'm going to do it this week in this video. Now, integration is actually the sum or the area under a curve for a given equation. Says you are given this equation, you have this sign, integration, meaning you need to know what's the area under the curve. Says you have a straight line, if you would have a straight line, and you are asked to look for the area from here to here. What's the area from here to here? Now, without the knowledge of integration, of course, in the basic maths, then is obviously this is a trapezium. If you were to have the height from here, it says maybe this is A length from here to here. This is A length. This is a B length, where A and B length correspond to the Y value. This is Y1, this is Y2 maybe. Yeah, and here would be my L, and therefore the area of the shaded region would therefore be the sum of the two over average, half of it, times the 90-degree L. Now straight away you memorize this equation, but we never ask where does it come from. For a straight line, it's straightforward. For a triangle, it's half base times height, so easy for a triangle. Right angle triangle, maybe this is B, this is H. You know the area will be straight away 1 over 2, B and H. This is what we have learned. This is what we were told. But now, in Form 5, Chapter 3, you will get a more detail of how do you get those equations. But we're not going to cover, I'm not going to prove this equation. But says if you are given a curve and you are asked to look for the area under the curve, then the integration should be the answer. Now to start off with, we're going to start with definite integral. What does it mean by definite integral? Here. Definite integral. Now, definite integral comes like this. Says from now, integration is basically area under the curve. I want to say area. If you want to look for area, integration says from A to C of a function fx. So this could be any function. You should go back to my previous video 1, to look for this. So it's from, says the curve should look like ambiguous, right? I mean a small curve. Maybe put it here. A positive x direction, 0, going up in a positive y direction. Now if my curve is positive value, maybe curve up. Now for now we deal with only positive x, positive y direction, positive y. Following on, I'm going to show you what happens if the curve into the negative y. So for any positive y direction, and you are asked to look for the area, maybe this value. This is my a value, and this is my b value. The area under curve, you can't basically use the simple trapezium law, because trapezium equation doesn't work here anymore, because it's not a straight line. This is not a straight line anymore. You can't treat this as a straight line. It's a curve. Now, in order to do that, we split them. We split that area into rectangles, and we sum all the rectangles, and it's called as Riemann sum. Well, maybe you can have upper Riemann, lower Riemann, or midpoint, but we will deal with midpoint Riemann sum. Or there are some name called trapezium rule, would be other name given, but they are all the same concept to get the area. Now to do that, let's expand one area of this. We have a curve. We draw that x, 0, y. Now if I were to have a curve, now what it does for Riemann sum is it split them. Well, maybe this is my a value. It split them into a very tiny rectangle in the midpoint, in the middle point. It serves as a middle point. Split them into tiny little point from A to C. Then eventually you get the area. So this rectangle will have the same value of, we call this a small change of del x. Small changes of x, they are going to have the same, you split them into have the same changes of x, small x. They are all the same. All you need to do is sum them individually, and eventually you comes up to have a general equation. Now, I have another video on putting them into Excel and get sum on the curve. Maybe you can look into my YouTube video. For the purpose of SPM, the concept of integration is up to here. So, in the event that you need to look for the area A to C of a function, what you need to do, you integrate this, eventually you get an equation. From there you get capital Fx C subtract A. There's a difference how I write my limit. Initially here, over the left, I start my number with the lower limit and then to the upper limit. But once I get the integration, I get the equation, I start with my upper limit over the right hand side, followed by lower limit. Now, why is it important? We'll show you why. Why do you need to see what does it mean in the next page. I'm going to show you an example later. Now we will deal with the facts at the moment. Now, in integration, just now have a to c fx dx. So it would have a function c to a. Now if you want to differentiate this kind of equation with a number, you doesn't need to have a constant c here, because it will subtract off later. And what you do is you substitute c into a function and you subtract with f a, capital F, small f. That's a difference. Now if you want to rearrange them, what you get here is basically a negative outside. Factorize them. A subtract fc. What you will get here will be a negative of an integration of c, or a here, c fx dx. Now what I want to tell here basically is, if you switch the limit, if you realize I've switched the limit is now switched. This is from c to a. This is from a to c. You read from the lower limit. There are questions in SPM. What happened? They ask a simple 2 marks question. If you switch the limit, what happened? All you need to do is you get a negative value. You need to get a negative value. Maybe I will look for a question and I will show you how does it work. A simple one, maybe. An equation that looks like, yeah, okay. Example A. Shaded area, you will find integration or definite integral from 1 to 2, smaller number, from 1 to 2, of a function maybe x squared minus 2x plus 1 of dx. Now to integrate this, you should go back to video 1 to show how to integrate. Straight away I will get the answer, because you may integrate 1 by 1. 3 minus x squared plus x without c, because this is a definite integral, 2 of 1. Then you substitute them, use a calculator, scientific calculator. I hope you will know how to use a bracket, super bracket. That would be 2 cubed over 3 minus 2 squared plus 2 minus top 1 subtract lower 1 would be 1 cubed by 3 minus 1 squared plus 1. Press on enter, you should get the answer. It's 2 over 3 minus 1 over 3. That would be 1 over 3 unit. Squared is area, that's why you have squared. So this is basically what you get. Now B. Calculate or estimate what happened now for the same equation up there. Integration of maybe 2 to 1. Then for the same equation dx, then you should expect to get the answer to be a negative 1 over 3. So this is what it meant by what I have learned in the previous page. Now, because over here that would be 1 over 3 subtract 2 over 3 short, you have this answer, you add a negative in front, you get the answer. Simple as that. Now there are instances when your curve, and it would be nice that you sketch a curve. Normally it should be in a curve form, that the curve or the integration over the negative y direction. That would be really cumbersome, because you won't normally get the answer. You won't get it right. Now say, for example, the following question. If I were to have a graph, it would be nice if you know how to sketch. You should be able to do so, because in Form 4, Chapter 3, you should refer to my video, Form 4, Chapter 3, technique to sketch a curve. First of all, look for what's the x-intercept, then look for what's the y-intercept. Would it be a positive, would it be an N curve or U curve? Now, say I have a sine curve, or maybe a curve that looks like this. If I were to have this kind of curve, and you were asked to look for the area under the curve from here to here, so you need to pay extra attention over here. This is a negative y, maybe this is A, and this is C. In order to get the area, for this curve, I will name this curve as fx, y equals fx curve. Then I will say, oh, okay, you will still be able to write this A to C of this curve. But in terms of integration method, it would be nice. This would be my b, another value. What happened? You need to integrate separately. First of all, you integrate this region. This is a positive y, so it's easy, because if you integrate, or I mean, you rewrite this, it will be integration a to b fx, the positive y region, you plus integration b to c of the function dx, and extra thing I want you to do is you get a modulus. You get only the positive number of this negative y part. This is important and crucial, because you will get a negative value here. So you get, and eventually you should get the answer. Okay. So two things you learn here. One, if you want to integrate one a to c, is basically is ab plus bc. First concept. Second concept, if it were to be negative y, then you need to include a modulus. Takes only the positive value. Now, next, you should go through the exercise or texts or any exercise book from any publisher, and do some practice and check your answer. I'm sure you can handle this by now. Just pay extra attention when it is a negative y, and you should be able to sketch it. For every question, I would advise my student to sketch a graph. It's not too hard, it's manageable. Now, the following part would be volume generation. Just now we have gone through area now would be of volume. For any volume that you have, how is it possible to get a volume? I mean, you will ask, this is only 2D and there's no way to get a volume, but I will show you later how. This is next will be volume generation by integration. Now, to start with integration, let's start with the basic concept of volume. Imagine, not imagine, I mean, when we were in a lower form, we were given a cylinder. Okay, it's not straight, but a cylinder. It's a straight cylinder. I mean, maybe. Let me draw this. Try to make it straight here. Okay, sideways. Easier. Okay. Cylinder. Okay. Now, start with a cylinder. You should always come back to this basic principle. I found it very useful in integration, how to use it. Now, and this is my R, radius, R. In order to get, this is the volume, H, height. In order to get volume for cylinder, that would be pi r squared. This is the base area of cylinder, of circle, area of circle, and you times with H, height. Pi r squared times height. No doubt, easily, you can get this easily. Now, how am I going to make use of that? Then it comes to Cartesian point. Into Cartesian, if you have a crazy curve, I don't know why it tends to go to the right. Okay. X, Y, 0. For any curve, maybe black, says what happened now if my curve is a U curve up, and then you'll be able to find actually, maybe from here, this length to this length, maybe A to B. We know how to find area. We should be able to know how to find area. But what happened? This curve rotates around the x-axis, meaning it revolves 360 degrees around the x-axis, where the x-axis is now the rotation axis. You will get a very funny object. An object will generate a volume. No, right? In the front, I mean, it goes around. If we were to rotate 360 degrees, you would get an object that looks pretty much like, I mean, a vase, maybe, yeah. Now, this is the core concept. Is it possible to rotate around y-axis? Yes. If it's possible to rotate around x-axis, definitely for sure this curve is capable to rotate around y-axis. But before we go to that, let's focus on the x-axis. Same rules apply, but let's compare with the general equation that we have, pi r squared times height. Now, to do that, first of all I want you to do would be go back to my earlier video, earlier part of my video, we define the meaning of integration as in area. Now, here you can't do it in one sum. What can you do is we separate them into parts. In order to get the area, what you do is you separate them into parts. Chop them into tiny pieces, maybe this one. Small pieces. Oopsie. Okay, undo. It's good to have technology. So at once. Put them into rectangle. Rectangle, so small. The smaller, the better. You chop them into 1 million pieces. So small. So small. With the same x, called same thickness, called small change, you call dx maybe, small change of x. Some books, they write triangle x, but dx. Since we are doing integration, we use dx. We'll stick with dx. And therefore, if one were to look for the area here, you need to have r squared and your h. Your h is the height. So based on this object, your height, and then you sum them, that will be your dx. So therefore, in order to get the volume would therefore be the integration pi by r squared. R is the radius, is always the y value here, y squared. My h, the height, would therefore be dx. And then you need to have a limit from a to b. I'll give you some time to read on this video. You may also pause my video. Revolution of 360 degrees. Yeah, then you get this. If it were to be only 180, then you need to half them. Then you may simplify it, of course. How are you going to integrate? A constant, you just bring it out. A to b, y squared dx. That's the reason to why you should go back to video 1 to practice on integration. Then y squared, what you do is either you expand it or you use the law for integration. Please don't confuse yourself. This graph, this function called fx, this fx is in the positive y direction. Even if you rotate it over the y, over the negative y, you doesn't need to have a negative value, because this graph originally is in the positive y direction. So even if you rotate it, revolve it 360 degrees, it doesn't need to have a negative or a modulus. No need for this case. In the event that if it were to be a negative y, then only you have a modulus. This is positive y, so no modulus for 360. So if it were to be 180 degree, 180. If it were to 180 degree, then therefore your volume should be pi by 2. A to b, y squared dx. Then if it were to be only 90, then it's 1 over 4 quarter. Pi by 4. If it were to be 90 degrees, the concept. The same is true. Normally, SPM in the past few years, there comes to be this form and a student can do it. You just need to learn how to expand them or how to differentiate this kind of curve. Go back to my video 1 and practice by using your books, any reference, any exercise, past year question that you have. Now, what happens if a curve is rotated completely about y-axis? Says now you have a curve that looks like positive x by positive y. Thing changes now. If a curve is maybe look like this, okay, doesn't need to worry at this moment what's the curve look like, but now y equals to fx. Oh no, sorry, if it were to be like this, it wouldn't be y anymore. Maybe the graph would, the equation would be, says, never mind. We use up the concept first. Squared, and it revolves around the x-axis. So maybe it's from A to B. Goes around y-axis, then 360 degree around it, and definitely you will get an object that looks like this. Volume. So the same concept applies. So here would be your x value, because this is 0. This is where the x value is. And then in order to get, first the concept would be to get the area. So you split them into Riemann midpoint, maybe into square in the rectangle, into many tiny little rectangles. So what you will get in comparison, compare with the cylinder, we have V equals to pi r squared times h. Compare with this general equation we have. So my volume 360 degrees around the y-axis will therefore be pi will be outside. Integration is standard form, A to B. Now what's my r? Radius. Radius for this weird object. The r would therefore be the x squared. And my h would therefore be, this is my dy. Small changes of y, of each individual rectangle. dy. This is how it should look like. It's not hard. First of all, you determine what is the radius. If you determine the radius is now x, and therefore the height would be height value. This is my dy over here. Compare with a cylinder. It's nice. It would be nice if you sketch it. No marks will be given to exam, but if you sketch it, it helps you to see better. Maybe we try one question. For volume, or you should go into any books and look for any question. Approach your teachers at school for SPM based question. But for here, let me start with one simple one. example. You were given a curve y is equals to 9 minus x squared, and then a line y equals to 3 and y equals 6. You were asked to find out what's the volume about the y-axis completely meaning 360 degree, and you were also given a curve. So this is sometimes you just do with 9 minus x squared. That would be what? 3 plus x, 3 minus x. So you will know that there's a 3 and negative 3. But you just need to sketch it because it's given an equation. You were given an equation that looks like this. A curve that looks like this, and this is where y equals to 3, and this is y equals 6. This is y equals to 9 minus x squared. It's given in the question. It's given in the question. So what's the volume? Volume covers here. So to start with, the concept here is pretty straightforward, this question. So volume, y-axis 360 would be general equation, pi integration a to b. That would be my a value, lower level. Here is 3, this is my 3, this is my 6, because y equals 6, so from 3 to 6. X squared, because this is my radius now, because go around it, x squared, and dy. Okay? Then from here you compare how to get your x squared. X squared is 9 minus y. You switch them around, and therefore you integrate this. Oh, okay. It's a forming equation. How do you get x squared? How do you get x squared? X squared is bring over. You get 9 minus y. And then you rewrite this equation. You copy from above. Integrate them correctly. This is 9y minus y squared over 2. This is 6/3. You have an equation. You have a scientific calculator these days. You were able to just key in this part. You get the answer. Look into your menu, your scientific calculator. It should give you the answer, and then eventually you will get the answer to be 13.5. Don't forget about your pi, and this is volume, so therefore it's unit cube. Should be the answer. Okay, the ability to get x squared from here. That's how you get to here. This is equation, general equation. Well, I hope you like my video. If you're watching my YouTube channel, do like my video, share it with your friends, drop me some comments so that I can improve to help more people. I can't afford to go through various types of questions because of time constraint. Maybe in future I would, but for now, the theory, the concept, the application, this is it. This should be one of those questions that you should choose to do in SPM. It's easy if you have done sufficient practice. Well, what else? You may go through my video. Let me know if you understand it. Drop me some comment. I will reply you promptly as soon as I receive it. I will do it. That's all for now. Stay tuned for my next video. Thank you.